The search for planets beyond our solar system has transformed our understanding of the universe. Each new discovery brings us closer to finding worlds that could support life. Imagine planets orbiting distant stars with conditions similar to those on Earth, places that might have liquid water, moderate temperatures, and atmospheres capable of nurturing life. These exoplanets, whether they're nearby or light years away, spark our curiosity and raise the question, could we be alone in the cosmos? In this video, we'll explore some of the most promising exoplanets and reveal why scientists consider them potential homes for life. We'll dive into the essential conditions for habitability and examine the most groundbreaking discoveries in modern astronomy. Get ready to journey beyond the stars as we search for worlds that might one day be new havens for life. What makes a planet habitable? Defining a habitable planet goes beyond simply asking if it could host life. To be considered habitable, a planet needs to meet several specific criteria. The first and most crucial requirement is the presence of liquid water, as all known life depends on it. Additionally, the planet's temperature must fall within a range that keeps water in its liquid state and is suitable for key biological processes, such as organic molecule formation. Another essential factor is the planet's position within its star's habitable zone. This zone is a region where the distance from the star allows moderate temperatures, preventing water from boiling away or freezing solid. In our solar system, Earth sits perfectly within the sun's habitable zone, creating an environment where life could emerge and evolve. Around other stars, the habitable zone varies based on the type of star and the amount of energy it emits. Beyond temperature and water availability, a planet's atmospheric composition is also critical for habitability. An atmosphere protects the planet's surface from harmful radiation, retains heat, and stabilizes the climate, creating a favorable setting for life. The presence of gases like oxygen and carbon dioxide can hint at past or present biological activity, making such planets particularly intriguing for scientists. A suitable atmosphere also regulates environmental conditions, shielding the planet from extreme climate shifts. Lastly, geological characteristics play a vital role. Tectonic activity, for instance, recycles essential nutrients and keeps the atmosphere balanced by absorbing excess gases. This geological activity supports planetary stability and sustains an environment conducive to life. Therefore, the presence of a solid crust and dynamic planetary systems are key factors in identifying a potentially habitable exoplanet. The discovery of exoplanets. The discovery of exoplanets is one of the most groundbreaking achievements in modern astronomy. Until the early 1990s, scientists weren't certain if planets existed beyond our solar system. Today, we know our galaxy is filled with them, with thousands of confirmed exoplanets in various star systems. These planets were first detected using advanced techniques, like the transit method, where telescopes observe small dips in a star's brightness caused by a planet passing between the star and Earth. Another key technique is radial velocity, which detects the slight wobble of a star due to the gravitational pull of an orbiting planet. One of the primary drivers of this revolution was NASA's Kepler Space Telescope, launched in 2009. Kepler observed hundreds of thousands of stars in a small section of the sky, detecting subtle light changes that indicated orbiting planets. Kepler's discoveries didn't just confirm the existence of exoplanets. They also revealed a vast diversity of planetary types, from massive gas giants like Jupiter to smaller, rocky planets similar to Earth. Kepler's success reshaped the field and paved the way for new missions, like the TESS, Transiting Exoplanet Survey Satellite, which continues to scan the galaxy for exoplanets, particularly those in habitable zones. TESS focuses on stars relatively close to Earth, increasing the chances of finding exoplanets that can be studied in detail. Each exoplanet discovered brings us closer to finding an Earth-like world and raises the possibility of encountering planets with conditions suitable for life. This new era of exoplanet discovery not only expands our understanding of the universe, but also fuels the hope that somewhere there may be a world with conditions similar to ours. As new telescopes and technologies emerge, the dream of finding a truly habitable planet draws nearer. With each new discovery, we take a step closer to answering one of humanity's greatest questions. Are we alone in the universe? The habitable zone, a crucial factor. One of the most critical factors in determining a planet's potential habitability is its location within the habitable zone of its star, also known as the Goldilocks zone. This is the region around a star where conditions might allow liquid water to exist on a planet's surface. Too close to the star, and the heat would likely cause water to evaporate. Too far, and it would freeze. For life as we know it to develop, water in its liquid state is essential, making the habitable zone a primary focus when astronomers assess a planet's potential to support life. The size and temperature of the star itself heavily influence the boundaries of this habitable zone. Larger, hotter stars like blue giants emit far more energy, pushing the habitable zone farther out, whereas smaller, cooler stars, such as red dwarfs, have much narrower zones closer to the star. This variation means that, depending on the type of star, habitable zones can differ significantly. Interestingly, red dwarf stars are among the most common in our galaxy and often have planets within their habitable zones, although these zones can be affected by intense stellar flares. In our own solar system, Earth is situated perfectly within the Sun's habitable zone, allowing for the stable, temperate conditions necessary for life. Other planets, like Mars, lie near the edge of the habitable zone, explaining why it has frozen water but lacks the warmth to sustain liquid water on its surface. Studying how the habitable zones vary among different star systems helps scientists identify which exoplanets could potentially harbor life and which are less likely to be suitable for life as we know it. Finding planets within a star's habitable zone is just one step. Other factors, such as the planet's atmosphere, composition, and the stability of its orbit, also play essential roles in its habitability. But by focusing on planets in the habitable zone, astronomers narrow down their search to the most promising candidates, worlds that could one day provide a new perspective on life beyond Earth. Atmospheres and the potential for life. While locating a planet within the habitable zone is crucial, having the right kind of atmosphere is equally essential for supporting life. A planet's atmosphere not only regulates its temperature, but also shields the surface from harmful cosmic radiation, such as solar winds and ultraviolet rays. An atmosphere can create a stable environment, allowing life to flourish if it contains the right balance of gases. Earth's atmosphere, for example, contains a delicate mixture of nitrogen, oxygen, and trace gases like carbon dioxide, which together create ideal conditions for sustaining life. A planet with a strong atmosphere can also retain heat, helping to regulate surface temperatures and making it less susceptible to extreme climate variations. This phenomenon, known as the greenhouse effect, is beneficial in moderation. It keeps temperatures within a range that supports liquid water, which is vital for all known life forms. However, if a planet's greenhouse effect is too strong, such as on Venus, temperatures can become dangerously high, rendering the planet inhospitable. Therefore, scientists closely examine the composition and density of exoplanet atmospheres to assess habitability potential. One exciting possibility is the detection of biosignature gases, chemical compounds that could indicate the presence of biological processes. For instance, oxygen and methane are often produced by life forms on Earth, and their detection in an exoplanet's atmosphere could suggest similar biological activity. Modern telescopes, such as the James Webb Space Telescope, are designed to analyze these atmospheric compositions from light spectra, allowing scientists to search for such biosignatures. Although this research is still in its early stages, it represents one of the most promising methods for identifying potential life outside our solar system. Finally, atmospheres also influence a planet's geological processes, including tectonic activity, which plays a crucial role in recycling essential minerals and maintaining the atmosphere's balance. A dynamic atmosphere, combined with geological activity, could make a planet more resilient to changes, further stabilizing conditions for life. By studying these factors, astronomers narrowed down the list of potentially habitable exoplanets, highlighting those with atmospheres that may create the necessary conditions for sustaining life. Notable exoplanets in the search for habitability. As our understanding of exoplanets expands, several candidates stand out in the search for potentially habitable worlds. One of the most famous is Proxima Centauri b, located just over 4 light-years from Earth. This planet orbits Proxima Centauri, the closest known star to our solar system. Proxima Centauri b lies within its star's habitable zone, leading scientists to speculate about the potential for liquid water on its surface. However, its proximity to a red dwarf star raises concerns about stellar flares and radiation, which could challenge its habitability despite its ideal location. Another intriguing candidate is TRAPPIST-1e, one of 7 Earth-sized planets orbiting the ultra-cool dwarf star TRAPPIST-1, located about 40 light-years away. 3 of these planets are situated in the habitable zone, making them prime targets for study. TRAPPIST-1e, in particular, has garnered attention due to its size and proximity to the habitable zone, suggesting that it may have conditions suitable for life. The discovery of multiple potentially habitable planets in such a close system provides exciting opportunities for future research and comparative analysis of planetary atmospheres and compositions. Then there's LHS 1140b, a super-Earth located about 40 light-years away. This planet is larger than Earth, which might provide the necessary conditions for a thicker atmosphere and potentially more geological activity. LHS 1140b orbits within the habitable zone of its host star, and recent studies suggest that its atmosphere could be analyzed for biosignatures, offering insights into its capacity to support life. Such investigations could help us understand how different planetary environments might sustain or inhibit life. Lastly, Kepler 452b, often referred to as Earth's cousin, is notable because it resides in the habitable zone of a star similar to our Sun. While it is about 60% larger than Earth, its location in the habitable zone and its star's characteristics make it a compelling subject for further study. As research continues, the data collected on these planets may help answer fundamental questions about life beyond Earth and the various environments in which it could thrive. Each of these exoplanets represents a unique piece of the puzzle in understanding what conditions make a planet truly habitable. The future of exoplanet research. The future of exoplanet research holds exciting possibilities as technology advances and our methods for exploring distant worlds improve. Upcoming missions, such as the NASA James Webb Space Telescope, are set to revolutionize our understanding of exoplanet atmospheres and their potential for habitability. Webb will enable astronomers to analyze the light that passes through exoplanet atmospheres during transits, searching for chemical signatures indicative of life. This capability opens a new chapter in the quest to discover habitable worlds beyond our solar system. Additionally, future telescopes, such as the European Space Agency's Ariel mission, are specifically designed to study the atmospheres of exoplanets. Ariel will focus on a wide variety of planets, including those in the habitable zone, to better understand their compositions and climates. By collecting detailed data on a range of exoplanets, these missions will enhance our understanding of how diverse planetary systems can be and how different conditions might support or hinder life. As we venture further into the cosmos, we may also develop new methods of exploring these distant worlds. Concepts for missions that would send probes to nearby star systems could one day allow us to gather data from exoplanets directly. These advancements could provide unprecedented insights into the conditions on these worlds, revealing whether they truly can support life. Ultimately, the quest to find potentially habitable planets will continue to inspire generations of scientists and dreamers. Each discovery not only expands our knowledge of the universe, but also brings us closer to answering one of humanity's most profound questions. Are we alone in the universe? As we look to the stars, the potential for discovering new life, and perhaps new homes, remains a tantalizing possibility that drives our exploration of the cosmos. Thank you for joining us on this journey through the fascinating world of potentially habitable planets beyond our solar system. As we continue to explore the cosmos, we uncover not only the mysteries of distant worlds, but also the profound questions about our own existence and the possibility of life beyond Earth. Each discovery fuels our curiosity and inspires us to look toward the stars with hope. If you enjoyed this video and want to stay updated on our latest explorations into the universe, be sure to subscribe to our channel. By subscribing, you'll never miss out on our future videos that delve into the wonders of space, science, and the search for life beyond our planet. Your support helps us continue to bring you captivating content and discoveries from the final frontier. Thank you for watching, and we look forward to seeing you in the next adventure